Hello, everyone. This is Krista Tweed, Applications Engineer with HBK, and we're back for part 2 of perception tips and tricks. In this case, I've had a customer contact me and let me know that he's not seeing the power values he expects in his data. So he shared a PNRF file with me, which I just opened with perception, and I'm going to take a look at the power traces and just see if anything jumps out at me. So I've got the total active power here, P, and then for the individual phases here. And it's a little easier for me if I change these to where they have different colors so I can kind of see what's what. And say, okay, now it seems a little bit strange here that phase 2 goes in the opposite, has a slope in the opposite direction of phase 1 and phase 3. I generally would expect all 3 phases of the power to have generally the same behavior. So when I see that's the case, my first step is I'm going to right click and say new user sheet, and let's just take a look at those raw data values for the voltages and the currents. So I'm going to open up my data sources, and under active inverter out, let's grab I1, I2, and I3, click and drag them over. And now I want to add to that, I'm going to overlay U1 on top of I1. And I'm doing the lowercase u's and i's because those are the raw data, not the RMS. And let's grab U3 and put on top there. So I'm going to drag my cursors into the data and then make this a little bit wider so I can see my full channel name. Put the current on top. And now I've got that red cursor at a point of interest. So let's just zoom in. So I'm going to click on this plus sign down here, zoom in on the data. And we've definitely got something funky going on here. You can see for U3 and I3 that the current, the peak of the red trace, is just a little bit ahead of the peak of the blue voltage trace. But on these other 2 phases, we've got a big difference. So you would expect it to be consistent between the 2. And if I look here, this peak in the red is pretty darn close to that peak in the blue. So I'm going to swap these 2 currents, move I1 down and I2 up. And now that looks like a much better match to me. So I think what happened here is that there was a wiring issue. And the user, when the power analyzer was wired up, what was actually phase 2 of current was connected to channel I1, and what was phase 1 of current was connected to channel I2. So now, what do we do about this? Because the test engineer would really like to not have to retake the data. What are our options? Well, Perception also has a post-process formula database in addition to the real-time formula database, where you're typically going to grab your real-time results for the power analyzer. And there's a lovely feature that I think was added in Perception 8.4 or so. If you go to the ePower Suite sheet, the tab at the top, and go to the menu, there's an option for create review formulas from active recording. So what that means is Perception's going to create post-process formulas for calculating all the same power calculations that were done in the real-time formula database for this recording will be repeated automatically in the post-process formula database. So I'm going to click that. It's warning me it's going to overwrite everything in the formula sheet. And I said, that's fine. So I do that, and it creates those formulas for me. So now I've got my variable assignments, my cycle detect, my RMS of phase-to-phase voltage, RMS of current, RMS of voltage. Everything that was in my real-time formula database is repeated here. And what I need to do is say, I had a wiring issue. Phase 1 is actually connected to channel 2, and phase 2 of current is actually connected to channel 1. And so now if I expand my formula data source and go under inverter, now let's create a new sheet and let's look at these results. So I have I1, I2, I3. There's my currents, and I want to put those with close active and make sure I'm grabbing them out of my post-process formula database. And I want U1, U2, and U3. And let's just do a quick check here and make sure that that looks like everything's matched up correctly. And that is looking good. So now let's grab those power values again. If I take P1 and I click and drag it onto the divider, it'll create a new sheet for me. P1, P2, and P3. I'm going to right click and say auto scale everything on that page. And if I zoom out and auto scale again, now we have all three phases where everything is looking consistent. We don't have one going the other direction. So this particular test engineer would be able to say, I don't have to repeat my test. I can simply come into my formula data source and now look at my active power values. I can pull the total power value in here as well. Auto scale it. And without having to do a whole nother test, take up more time in the test cell, I'm able to correct that wiring issue and see the results of my test.